As we continue with 2.6, we have kind of a hodgepodge of different equations we want to solve. Some are easy, some not so much. The first thing we're going to do is talk about absolute value equations. And so I have other videos on like the whole story. But what an absolute value means, the fast version of the story is this. What an absolute value means is that I'm just interested in knowing, for instance, how far away I am from zero. Someone wasn't all that concerned. Well, I should do it like this. An absolute value is a math shorthand for saying how far away am I from zero. And what a mathematician wasn't interested in the signs. They just wanted to know the distance. And so they created this idea of an absolute value. So both 9 and -9 are 9 steps away from zero. They're both the same number of steps. And that's all the mathematician was interested in knowing, was just how many steps. Now that's what's going on behind the scenes. But when we solve an equation, what we need to remember is that what was inside of there could have been a positive value or it could have been a negative value. So we have to work it twice. Now there's a little bit more to this story too, but what you're going to go ahead and do is work it once as if x plus 4 equals 8. You're going to work just what's there. Then you're going to work it again as if it equaled -8. So what we're doing here is we're compensating for the fact that what's inside of there could have been a positive value or it could have been a negative value. And here's the easiest way to do that. Now we solve each of these for x and we get two solutions. Now here, the second one, we have a trick. Do you notice we have an absolute value being equal to a -9? Now this can't be true. There's no way. So if you have an absolute value equal to a 0 or a negative, just pause and try to think through the logic of what might be happening there. And so when I have it equal to a negative, I'm going to stop and think, wait a minute. An absolute value always makes a positive number, so there's no way it could equal a negative. So this has no solution. Now on our third one here, we're not going to do that trick where you just do the positive and the negative until we want this problem area, this 3x minus 5, this absolute value, we want to get that alone, and then we'll do the trick. And so what I mean is, if this was x minus 4 equals 6, what I would do is I would add 4 to both sides. Well, that's what we want to do here. We want to isolate the absolute value. I add 4 to the other side, and now I have this. Okay, well now we're ready for the trick where I'm going to work it once where it's equal. I'm going to work it a second time, or I should say this, work it once for positive 10, work it once for -10. Now this equation here does not violate our principle about the negative square roots, or the negative absolute values. This is okay. When we were at this point right here, it was not a negative. So now we're going to do the trick and we're going to create one with the negative, but that's different. We're no longer doing the absolute value. So as long as this is a positive at this point right here, we're okay. And then we're going to work the two equations individually. So we're fine. Solve it down, we get our two solutions. Okay, now when it equals 0 here, we're going to have a unique thing occur. So I could work this twice. I could do -5x plus 10 equals 0. But I could also do -5x plus 10 equals -0. Well, -0 isn't anything. It's the same thing. So if you have it equal to 0, there's only one value that's going to make that true. And here this one solves down to be x is 2. Okay, so try this if you want to. But on this one, the key is I have to get the absolute value by itself. So I'm going to subtract 8 from both sides, first of all. I want to isolate the problem area, which is this absolute value. Okay, I've got the absolute value equals 5. Okay, now we're ready for our trick. We're going to do 1 minus 4x equals 5, and 1 minus 4x equals -5. Okay, we're going to solve this. Subtract 1, so dividing both sides by -4, I'm going to get -1. Divide both sides by -4 this time is going to get me, can you see this is going to be 6 over 4 or 3/2. Okay, so I'm not really sure how this all connects in the big picture. Like, I'm not sure why absolute values are in there. But we're back to looking at some equations that have a degree that's higher than 2. Now, what we would typically do here is we would factor. But so we had a GCF the last time we saw this. We could take a GCF and that would solve the issue, but we can't do that here. I need the right side to be equal to 0, which it does. But what I need here is I need to factor this. Well, how can I do that? Well, it's because of this. Because x to the fourth and x to the second is going to follow the same pattern as if this said 3x squared minus 2x minus 1. It follows that same pattern that can be factored for a trinomial. Now, I don't know if they showed it. Yeah, they did. Here's the trick. What we're going to do is we're going to make a substitution. We're going to say, hey, let's let u equal x to the second. Now, why is that going to work? Well, what would happen? If u is x to the second, that makes this x squared into a u. And x to the fourth would then become u squared. You say, well, what's the big deal? Well, we know how to factor something that looks like this. So we will. Factor this out, and then this would be the AC method or the guess and check. They've guessed and checked it here, so it factors down to this. We won't take time on the factoring, but factors down to this. Okay, well, let's solve those, just like we would before. Well, we'd get u as negative 1/3, and we'd get u as 1. But this was not a problem about u. It was one about x squared. And so we made this clever little substitution up here. We need to now undo it. We're going to take that substitution out. And so if u is negative 1/3, then x squared must be negative 1/3. And if u is 1, x squared must be 1. And then we can finish solving those by square rooting each of those. Now notice that this made a complex number, an imaginary number, because of the negative if you square rooted that. That's how they got down to this complex number. Now, once again, this is why I know it's wildly inconsistent, but we're doing quadratics, and so when we take a square root, we need to think of it as plus or minus. Okay, so we're going to do that same trick here. Pause if you want to do it on your own. If I make u into x squared, I can turn this into something that I know how to factor. I know how to handle that. So I'm going to factor that down. So if you look for the two numbers that make negative 9, it's going to be, we're going to get this. Now, u must be 9 and u must be negative 1. But I am not interested in u. It was a story about x squared. I just made a little trick. So I'm going to replace the u back with x squared. Now, we're going to square root both sides. Okay, now plus or minus square root of 9, x is going to be plus or minus 3. And over here we have x is plus or minus, that's I. Square root of negative 1 is I. And there are my 4 solutions. Again, I know it's wildly inconsistent, but with quadratics, we want to take a square root and we want it to be the positive and negative. We're not just taking the principal root, we're taking both. Okay. Now, if you followed that last idea, you see, what are we supposed to do with this? Let's do a substitution again. If I make u equal to x plus 2, it turns into something that I can easily handle. I can make this u squared plus 11u minus 12. We factor that down and we solve. Well, they did this a little differently, so let's do it by. So I'm going to get u is negative 12 or u is 1. But I'm not interested in u. I want x. Now, we know u is x plus 2, so let's replace it with x plus 2 in both of these. And we solve it. We get this. Okay. Now pause if you want to try, but the key to this is I'm going to make this substitution. And if I do, this is going to make this, it's going to make this u squared minus 4u minus 21 equals 0. So this doesn't have an a in front of this u squared, so this is good old-fashioned. Let's just find two numbers that make negative 21 and add to get negative 4. Well, here we go. Solving this, we get u is 7, and u is negative 3. But we don't want them to be u, we want them to be about x, so we undo our substitution. So x is going to be 12, and x is going to be 2. Okay, now I do these out of order sometimes. I thought we've already tackled this in the first chapter, but maybe they weren't quadratic. So if I have a rational equation, it has denominators, like the idea of ratio is in there. So we have these denominators on the bottom. We want to get them all to have the same terms on the bottom. Do you remember this discussion? Let me see if I can use what they've done. No, too much. Okay, so the first thing I'm going to do is I'm going to factor anything that's not factored. We want to compare the factors in the denominator, but this on the bottom right is not factored. So I am going to factor it. So again, I'm almost certain we had some discussion of this in chapter 1. Okay, so now it's factored. Now I can compare factors. So do you remember this? He has the x minus 1, but he needs x plus 1. But if I give it to the bottom, I have to give it to the top. He has x plus 1, but he needs x minus 1. Give it to the bottom, I've got to give it to the top. Now he has everything. Now the reason we're seeing this again is I can tell we're going to make some quadratics here. We're going to make x squared. So I'm going to FOIL this out. Negative 4x times x plus 1 is going to be negative 4x squared minus 4x. Now here I'm going to distribute 4 to the, and I get 4x minus 4. Now all this equals negative 8. Now if you remember this discussion, again, I'm almost certain it was in the first chapter. If we're solving an equation, this denominator here, now that it all matches, is going to have nothing to do with solving it. So I'm not even going to write it again. It has no part in actually solving it. I'm just going to solve what we've created here, which is negative 4x squared minus 4 equals negative 8. Okay. So to solve this, there's a couple ways we do it. I'm going to use the square root property because you could factor this too. You could get there two different ways, but I'm going to just isolate x squared. So if I add 4 to both sides, I'm going to get negative 4 over there. If I divide both sides by negative 4, I'm going to get x squared is 1. Now square root this, and I'm going to get x is plus or minus 1. We're doing quadratics, so we want the plus and the minus. Now here's the problem with this. The only two solutions that I have are restricted values. Do you remember how we would look back and say, hey, what values would create a 0 in the denominator and blow up the math universe? Well, the numbers are 1 and negative 1, and those are my only solutions. So even though I got these answers, they are not acceptable, and there's actually no solution to this problem. So pause it if you want to try on your own. Let me just make sure. Yeah, this is our last question here. So I'm going to show you if you don't feel ready to go yet. I'm going to need all of these denominators to be factored. The game doesn't work unless you can factor it all down. So I'm going to take a GCF out of this last one, and I get this. Okay, now every denominator needs to have the same group of factors. So I'm going to give an x here. If I give it to the bottom, I got to give it to the top. This one needs an x minus 2. Give it to the bottom and give it to the top. And this last one has everything he needs. So I'm going to multiply out these numerators, the tops. I get 2x. Now, everything has been multiplied out. I'm going to leave the denominator out of it. It has nothing to do with the solution. It does not matter. So clean this up. Okay, now I'm going to I suspect that this is going to require, oh, hold on, I jumped ahead. I need to get everything on the same side. So I was trying to factor it and it wasn't going to work. Okay, so if I add 2 to both sides, these guys will both be gone. So we're going to have this. Okay, so this can be solved. Now when I'm looking at this, there's multiple ways we learn that we can solve this, but the fastest is factoring. So I'm going to pull out a GCF, and I would get this. Now set each of those equal to 0. So if solving that, I get x is 0, x equals -1. Okay, now let's check our solutions. There are restricted values. At any point in the equation, if it would create a zero denominator, it's an issue. So if you see 2 and 0 are my problems, well, x equals 0 was one of my supposed solutions, so it has to go. It's a restricted value, and my only final answer would be x equals -1. Okay, a lot of ideas there, kind of a collection of different more challenging ways to solve equations. Hopefully that made some sense. Rewatch this if you need it, but hopefully that'll get you started.